Now that we know what it means to solve quadratic equations, we're going to look at solving them by taking square roots. The time we want to use square roots is when we have an x squared term but no x term. So it's going to be in the form ax squared plus c equals y, as opposed to ax squared plus bx plus c equals y. Before we go over some examples with it, I want to look at the idea of taking square roots. So let's say, for example, we have 9. If we look at what two numbers squared give us 9, so in other words, we look at what the square root of 9 is, notice that both the number 3 squared gives us 9 and the number -3 squared gives us 9. The same thing is true if we look at the square root of 16. Well, what does the square root of 16 give us? Well, both 4 squared gives us 16, as well as -4 squared gives us 16. For that reason, whenever we take the square roots of two sides of an equation, we're always going to remember to get both a plus and a negative answer. So let's look at actually solving. Some square roots. So again, notice that we use square roots when b equals 0, so it's in the form ax squared plus c equals y or equals 0. So whenever we solve them, our goal is going to be to get x squared by itself. So on this first example, notice that x squared is already by itself. Once x squared is by itself, we can take the square root of both sides. Remember that when we take the square root of 49, we both want the positive and negative answer, so we do plus or minus the square root of 49. The squared and the square root cancel here, leaving us with x. Square root of 49 is 7, so I get positive and negative 7 as my answer. Notice I can plug both positive and -7 back into my original equation to see if they work, and positive 7 squared does give me 49. -7 squared also gives me 49. If I look at example 2, again, the very first thing I want to do when using square roots to solve is to get x squared all by itself. So doing that, I'm going to first add 27 to both sides. These cancel, and I'm left with 3x squared equals 27. Now I can divide both sides by 3, and I get x squared equals 9. All I have left to do to get x by itself now is to get rid of that square. I can do that by taking a square root. Again, remembering when I take square roots to take both the positive and negative square root. So taking the square root of x squared and taking the square root of 9, again remembering both positive and negative, my square and my square root cancel, giving me x equals both positive and -3. And again, I can go back and plug those into my original equation to check to make sure they work. Looking at this next example, I want to again first get x squared by itself, because again there is no x term. So getting x squared by itself, I can divide both sides by 6. My 6's cancel, and I do get x squared equals 4/6. Whenever I deal with fractions, I prefer to deal with fractions in their least common, or in their reduced form. So I'm going to divide both 4 and 6 by 2, giving me x squared equals 2/3. From here, I can take the square root of both sides. Again, when I do, I have to remember to do my plus or minus. I'm going to switch pen colors. So now taking the square root of both sides, when I take the square root of this side, again, I remember to put that plus or minus out front, and I get x equals plus or minus the square root of 2/3. And notice that whole thing is inside the radical.